Hello guys, this is Saket from Team Let's Learn. Today with me here is Tushar and he will be giving his Anglo interview in short period of time. So he is with us for a marathon interview session. So let's begin with Tushar. We'll start with some favorite questions of Anglo interviewers. We'll start with Braganza sir's questions. Okay. So okay Tushar, first question comes to you is explain centrifugal pump. Okay, explain centrifugal pump.
Okay, centrifugal pump is basically a type of pump which works on the rotodynamic principle. It has an impeller, a volute casing, a suction pipe, and a discharge pipe. It contains feed valve and a strainer at its suction pipe. It is a type of the feed valve is a type of it is unidirectional valve which allow the flow of fluid in a single direction but restricts its motion via the same passage. And a strainer is a type of filter which is at the bottom of the suction pipe for the filtration process only. So when impeller rotates, basically negative pressure is created at the eye of the impeller. Then passing from the feed valve and strainer, water is sucked to the eye of the impeller. Then via the backward guided veins, centrifugal force is imparted on the fluid, because of which fluid is moved toward the discharge side via volute casing. And a volute casing is basically designed in such a way that its volume gets keeps on increasing towards the discharge side. We know that if our volume is increasing, then our kinetic energy is getting converted into pressure energy, as our velocity will be decreasing because of the increase in the area. So this is how we get our discharge pressure in a centrifugal pump, and this is how basically a centrifugal pump works.
Okay, Tushar. So tell me, explain about VCRS cycle.
Okay, so vapor compression refrigeration cycle. Basically, this cycle involves four steps. That is isentropic compression, isobaric heat rejection, isenthalpic expansion, and isobaric heat absorption. So basically, let's start from the beginning. Let's start the story when the low temperature and low pressure vapor refrigerant enter in the compressor. Then compressor isentopically did compression over there, and from then then our refrigerant gets converted into high temperature and high pressure saturated vapor refrigerant. Then it passes to the condenser, where heat is rejected isobarically in the condenser with the help of a water cooling jacket, which where we use water to extract heat from the refrigerant, and it get converted into slightly less temperature but high pressure. As the pressure is not changing, it is an isobaric process. Slightly less temperature and high pressure liquid refrigerant. Then this refrigerant enters the dryer, where a dryer contains silica gel. It absorbs any moisture which is available there in the reefer system or in the refrigerant. Then this high temperature and high pressure liquid refrigerant enters the thermostatic expansion valve, where isenthalpic expansion took place, and then it moves away from a thermostatic expansion valve as a mixture of vapor and liquid refrigerant, with low pressure liquid and vapor refrigerant, 80% liquid and 20% vapor refrigerant, with of low pressure and low temperature. Then this low pressure and low temperature liquid and vapor refrigerant mixture is sent to the evaporator side, where isobarically it absorbs heat from the desired area. And then this refrigerant gets converted completely into low temperature and low pressure vapor refrigerant, as because of absorbing heat, liquid gets converted into vapor. Then it passes through sensing bulb. So sensor bulb so sensing bulb is basically an instrument which sense the temperature and pressure of the refrigerant, and via a capillary tube, then it sends signal to the thermostatic expansion wall that if the temperature will be above than the desired value or the predetermined value, so it will send a signal to the via capillary tube to thermostatic expansion wall that more refrigerant is needed. So thermostatic expansion wall will open its orifice more, and flow of refrigerant will be more in the evaporator. If the temperature will be below predetermined value, so thermostatic expansion wall will contract its orifice and restricts, or we can say that, or lowers the rate of flowing of refrigerant in the evaporator. And then again this mixture goes to the compressor, and this cycle goes on.
Okay. The next question is explain gear pump.
Okay, so gear pump is a type of positive displacement pump. Is a pump which basically works on the principle of positive displacement, and it uses two gear to create suction and to create discharge. Okay, so there are two gears used. One is called driver gear and other is called driven gear. Both are meshed together. Now, when driver gear is connected to a motor shaft, when motor rotates, so driver gear starts rotating as and since driver gear and driven gear are meshed together, so as a result both the gear starts rotating. As a result, when teeth of gears comes out of the mesh, as a result area increases. Now as area increases, then pressure decreases. So when pressure decreases, so a negative pressure region is created. Because of negative pressure region, we know that water or any fluid over there starts being sucking at that place. So now the teeth of the gear traps that fluid that is being sucked towards that area and displaces it toward the discharge side. Now when it moves to now the trapped fluid when moves to a discharge side, so the story happening over there is that the teeth again started coming into the mesh. When again start coming into the mesh, so our volume decreases or area decreases, we would rather say. When area decreases, so pressure increases. This is how we get a high discharge pressure at the discharge site of a gear pump, and this is how a gear pump works.
Okay. The next question is why do you close discharge valve before starting centrifugal pump?
Okay, so there is basically a graph between power and flow, which tells us if our flow will increase, then our power consumption will increase. And as we all know that before starting any machinery, it draws some current to overcome the inertia forces for starting that machinery. So if we are opening the discharge valve at that point of time, so at the starting current which centrifugal pump will require, it will increase tremendously, and we don't want power loss because power cost money. So that's why we keep the discharge valve shut, so as minimum power is drawn. And then when proper flow is over there and machinery has overcome its inertial forces, so then we open the discharge valve and we get our desired flow. To just reduce the power consumption, we did so.
Okay. The next question is how pressure is generated in discharge side of centrifugal pump?
Okay, so how pressure is actually I have answered this question in the working of the centrifugal pump, but
Yes.
in short, if I would say, then the design of volute casing is such that its volume increases towards the discharge side, and we know that pressure is equals to force upon area, and if our area is increasing toward the discharge side, so our kinetic energy that was being imparted on the fluid because of the centrifugal force gets converted into pressure energy, and as a result, if our area is increasing, so our kinetic energy is getting converted into pressure energy, and this is how we get desired pressure at the discharge size of the centrifugal pump.
Okay. Coming to the next question, what happens if air is present inside centrifugal pump?
Okay, so let us take two examples. First example is that if there is complete air present inside a centrifugal pump, if complete there is complete air inside the centrifugal pump, then we know that air is an incompressible fluid. So if a centrifugal pump will start rotating, it will try to impart centrifugal pump on air. But since air is a compressible fluid, so instead of getting displaced toward discharge side, it will get compressed from hot regions over there. As a result, our motor will run dry. Ultimately, it will damage the windings. The other is that if there is half water and half air, so we know that the density of air or any fuel is for now, let us take a fluid, water. Okay, we know that the density of water is 1,000 times the density of water, and if half water and half air will be present inside that, so we know that density is less, so mass will be less. So for generating that much pressure, which is what delivering earlier, for delivering that much flow, it will draw more power. So capacity will of pump will decrease, power consumption will increase, and it is not designed to hold. A volute casing is not designed for the forces of air, so ultimately our volute casing will also be damaged. Plus, yes, these are the reasons.
Okay. Then what is priming?
So priming is basically a method of removing air from the centrifugal pump and filling that gap with a fluid that is being sucked by the centrifugal pump.
Okay. Then working of VCRS, you told it earlier.
Yes, yes.
Then after, next question is temperature of evaporator or domestic refrigerator.
Okay, it basically depends on the type of refrigerant which we are using. For instance, if I would say that of a R134A, so for that type of refrigerant, if I would say, then the temperature at the freezer would be from -18 to -20 degrees Celsius, and for the vegetable section, it would vary from 4 to 5 degrees Celsius, and the temperature would vary from refrigerant to refrigerant.
Okay. Okay. Then next question is difference between reciprocating pump and gear pump.
Okay, reciprocating pump. Basically, in reciprocating pump, rotary motion is responsible for the suction and discharge pressure, and in the reciprocating pump, reciprocating motion is responsible for the suction and the discharge of fluid toward the discharge side. Flow rate is constant in gear pump. Flow is constant, whereas fluctuation in flow can be seen in a reciprocating pump. Reciprocating pump just uses more area, or covers more area, whereas gear pump do not cover that much area. Reciprocating pump require more maintenance, and our gear pump required less maintenance. Air blower is used in a reciprocating pump, whereas there is no need of air blower in the gear pumps. So these are the differences.
Okay. Then after next question is difference between centrifugal pump and positive displacement pump.
Okay, so first difference is that centrifugal pump works on rotodynamic principle, whereas positive displacement pump works on the principle of positive displacement. Now, priming is basically required in centrifugal pump, whereas priming is not required in a positive displacement pump. Relief valve is not used in a centrifugal pump, but in positive displacement pump, relief valve is used. Our flow is dependent on pressure in a centrifugal pump, whereas flow is not dependent on pressure in a positive displacement pump. And suction is created because of with the help of an impeller in centrifugal pump, and positive displacement pump, it can be created because of a diaphragm, a piston, a gear, a meshing of gears, or intertwining of screws. So these are the differences.
Okay. Then explain boiler mountings.
Okay, I have to explain all the boiler mounting, right? Okay, so basically, the boiler mounting, if we start, I would first name them, and then I would explain about
Okay.
that. So first start with the safety valve, then our scum valve, then steam pressure gauge, steam stop valve, feed check valve, then gauge glass, then boiler blowdown valve, then air vent cock, and then a fusible plug. So starting with the safety valve. So safety valve is basically there when the pressure inside the boiler is above the predetermined value. So it will just lift up and release the excess of accumulated pressure inside the boiler. Then we come to steam pressure gauge. It is basically a type of gauge which tells us the pressure of steam inside the boiler. Then we come on the scum valve. Scum valve basically eliminates that any impurities that is being floating on the surface of the water. Then steam stop valve, basically it controls the flow of steam from boiler to the other part. Then feed check valve, it basically ensures that proper amount of water is being delivered to the boiler for the production of steam. Then gauge glass basically tells us the water level inside the boiler. Then boiler blow down valve, whenever we have to clean the boiler to remove the sediments or any other impurities, so we use boiler blow down valve to empty it. Then we air vent cock. Air vent cock is basically used when we have to when we have to remove air from the boiler while filling the boiler, or while removing emptying the boiler. When we have to remove air from the boilers, an air vent cock is used. And fusible plug. So fusible plug is basically in the boiler, is below the water surface, is under the water surface. And basically when our water surface deteriorates to a lower level or to a danger level, then that fusible plug get exposed to the steam. And since it is a temperature dependent thing, so it melts. And as a result, when it melts, so all the water flows in the combustion in the boiler, flows to the combustion chamber, put off the fire. And this is how a boiler stops if the water level is below the security level. So this is how our boiler mountings, and these are the works.
Okay. And then the next question is Faraday's law and Len's law. Explain.
Okay, Faraday's law. There are two laws of Faraday. First law states that whenever conductor is linked or placed in a changing magnetic field, then an EMF is induced. And whenever that conductor from a closed coil, then that induced current flows through it. Second law states that the amount of EMF generate, or the intensity of EMF, is directly proportional to the rate of change of magnetic field.
Okay. Then
E is
Len's
equals to
law.
minus d phi by dt. And when it come on Lenz law, so Lenz law says that the magnetic field induced because of the induced current will always flow in such a will always be in a direction that will oppose the direction of the original magnetic field. So these are Lenz law and Faraday's law.
Okay. Then next is laws of thermodynamics.
Okay, so thermodynamics, starting with the zeroth law. So zeroth law states that basically if two bodies are in a thermal equilibrium with the third body, then those two bodies will be in thermal equilibrium with each other. Faraday's first law states that energy can neither be created nor be destroyed, just can be transferred from one form to another. That is delta Q is equals to delta U plus W. What type of the amount of input we are giving gets distributed in basically powering the system, and then work done. So 100% of work done cannot be achieved. And then we comes upon thermodynamics second law. So it consists of two statements, Clausius statement and Kelvin Planck statement. Kelvin Planck statement basically states that we cannot create a 100% efficient engine. And Clausius statement states that it is impossible to flow heat from a colder body to a hotter body without any external disturbance or external assistance. Now so thermodynamics third law states that whenever a system is in thermal equilibrium, so its entropy will approaches a constant value when the temperature of that system will approaches to the absolute zero, that is minus 273 degrees Celsius.
Okay.
So these, yeah.
Then after the difference between four stroke and two stroke.
Okay, so two-stroke engine, four-stroke engine. As the name suggests, is generated in two-stroke engine in two strokes, whereas it takes four-stroke in a four-stroke engine. Then the theoretical power output of a two-stroke engine is two times the power output of a four-stroke engine, whereas the actual power output is 1.5 to 1.8x to that of a four-stroke engine. Power to weight ratio is more in two-stroke engine than as compared to that of a four-stroke engine. Working pressure and working temperature are much higher in a two-stroke engine than compared to that of a four-stroke engine. Lube oil cost in a two-stroke engine is much lower than that of a four-stroke engine. And basically, if we would say, then long, sorry, if I would say to the thermal efficiency. So thermal efficiency, sorry, volumetric efficiency. So volumetric efficiency of two-stroke engine is less than that of a four-stroke engine. And two-stroke engine are basically used for high powered and low speed, basically in marine diesel engine like that. Whereas four strokes are used for medium powered engine, and a two-stroke engine is capable of burning cheap quality or low quality fuel oil, whereas four-stroke engine is not capable of doing so, because two-stroke engine have a big piston, big stroke length, whereas stroke length in four-stroke engine is less than that of a two-stroke engine. Now, if I would say, I think I have given so much differences. Now,
Hmm.
any difference I am hardly remembering.
Okay. Then after the question is safeties of compressor. Safety devices for compressor.
Lube oil low pressure alarm and trip, fusible plug, sorry, jacket water cooling alarm and trip, or water no flow trip, a bursting disc, and motor overload trip. Yeah.
Okay. Then safety devices of VCRS.
It is low pressure cutout, high pressure cutout, condenser, cooling water, high temperature cutout. Then it is master solenoid valve, and it is liquid shock valve, relief valve on the condenser side, and the oil heater for the compressor crankcase, and lube oil low pressure alarm and trip.
Okay. Then after what is the difference between reflection and refraction?
Okay, so reflection basically states that the reflected ray, incident ray, and normal ray lies on the same plane, and it is basically the it bounces reflected ray. Incident ray is reflected back with the same angle with the normal to that of the incident ray, but and it take place on in a single medium only. But when it talks about refraction, so whenever we incident a ray of light on a boundary of two mediums, then whenever the light enters from one medium to another medium, then its path got deflected, and this is what we call as reflection. It do not bounce back, but it's with the same angle, its path got deviated, and this is what we call as refraction.
Okay. Then what are boiler accessories?
So, if it talks about boiler accessories, then it is feed pump, uh, exhaust gas economizer, preheater, air preheater, and boiler superheater.
Okay. Then after working of fusible plug.
So I have already explained, but let me explain it again. So fusible plug in a, if I would say, let us take fusible plug is inside a boiler. So basically, it is under the water. Whenever the water level deteriorates below the security level, then that fusible plug get exposed to the steam, and we know that the temperature of steam is much higher than that of water. So basically, fusible plug melts, and all the water in the boiler flows towards the combustion chamber and lit off the fire, and this is how a fusible plug actually works.
Okay. Coming to the next question is explain Bernoulli's principle.
Okay, so Bernoulli's principle states that whenever an ideal flowing fluid, ideal and incompressible fluid is flowing in a streamline and between 2 points, then the total energy of fluid at the first point will be equal to the total energy of the fluid at the exit point or at the second point.
Okay. Then after explain Archimedes principle.
Archimedes' principle basically states that whenever we place any object inside in water or in any fluid, then upward thrust or upward thrust act on it, which is called as buoyant force, and that buoyant force is equal to the weight of the water displaced by that object which was being immersed in that liquid.
Okay. Then after Pascal's law. What's that?
So Pascal's law is basically says that in a confined space in an incompressible fluid, if we apply pressure, then it is directed equally in all the directions.
Okay. Then after, what is bursting disk?
So bursting disc is a basically a safety device, basically mounted for prevention from excessive of pressure that is being accumulated inside the machinery. Bursting disc is a type of disc, is a only one time use component, and it ruptures whenever the working pressure inside the machine is above the predetermined value. It ruptures and releases excessive pressure that is being accumulated inside the machine, and then we have to change it. Normally the it is designed for 1.5. The bursting pressure is about 1.5x the working pressure, sorry.
Okay. Then after, okay, did you told the temperature at what that bursting disk burst?
uh, Temperature, no, bursting disk will burst at a specific pressure. It is a
Okay.
uh, pressure safety device, not a temperature safety device. A fusible plug is a temperature safety device which melts at 232 degrees Celsius, but bursting disk will burst at a certain pressure, and that will be like designed just for 1.5 times the working pressure.
Okay.
So
Okay.
there is nothing to do with the temperature.
What is oil mist detector?
So oil mist detector is basically a safety device in the main engine which tells us the amount, which gives which basically tells us the concentration of oil mist in the crankcase, and thus prevents explosion in the crankcase, because we know that there is in a crankcase, lube oil is present over there for the splash lubrication, and whenever in splash lubrication, that lube oil is sent to the hot spot, so it become hot and gets evaporated, and when it comes to the cold region, it get condensed and get converted in the form of mist. And whenever again when that mist is sent to those hotspot, then that mist causes explosion, and to prevent that we have to check that what is the concentration of oil mist inside our machinery. So oil mist detector basically measures the concentration of oil mist inside our machinery.
Okay. Then after, what is NDT and explain magnetic detector?
So non-destructive testing is basically the type of testing in which we test the materials without breaking them or without causing any harm to them. If we talk about there are many types of NDT methods, that is magnetic particle testing, dye penetration testing, radiographic testing, ultrasonic testing, eddy current testing. If you are asking about magnetic particle testing, so basically it is used for a ferromagnetic material, and a paramagnetic or an electromagnet is used to create a magnetic field around the testing piece. And if there will be any leakage in the magnetic field lines which is created over there in the testing piece, will indicates the leakage or defect in the testing area. And this can easily be seen by spreading fine iron particles or any magnetic particles in that test piece over that magnetic field. And if distortion will be there, so because of those particles getting trapped in that cavity, so distortion can be seen easily over there with the help of those particles, and then we can detect that here it is crack and here it is not.
Okay. Then explain dye penetrant test.
So dye penetration testing, dye penetration testing, basically first we clean the surface, then we apply dye penetrant over the surface, and if there will be any leakage or any crack over there, so dye will get trapped in that leak or crack, and after that we remove the dye penetrant. Then we apply a developer over there. So what happens is that wherever the developer if the developer will be applied over that crack, so it will attract dye and it will change its color to red. So wherever we will see those red spots after applying the developer over there. So it tells us that here it was defect in the testing piece. So this is basically about the high penetration testing.
Okay. Then after moving to the next interviewer's favorite questions, that is Rishirana sir.
Yes.
His first question is that how do we come to know VCRS system have moisture in it?
Okay, if there will be noises in the compressor, then it basically tells us that moisture is present because water is an incompressible fluid, right? So it will create noises, tuck, 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 tuck in the compressor. And if there will be frost formation in the evaporator coil, then it is also an indication that, brother, there is something wrong in the reefer system. So these two things are, I think, main things which tells us that there is the moisture in the reefer system.
Okay. Then after why freezing takes place in evaporator coil?
Okay, basically, when we open the door of the refrigerator and moisture gets in contact with the moisture in the surrounding gets in contact with the evaporative coil, then we know that the temperature of the evaporator coil is very low because of the liquid refrigerant being flowing over there. So moisture gets attracted toward that to that evaporator coil, and because of the low temperature, it get freeze, and thus freezing take place in the evaporator coil.
Okay. Then after what are the parts of diesel engine?
Okay, diesel engine parts, if I have to say, then it is a cylinder block, then piston rings, then uh, connecting rod, then crankshaft, then camshaft, rocker arm, turbocharger, and fuel injector.
Okay. Then after coming to the next question is what is piston ring and its function?
Okay, so piston rings are basically rings on the piston, and the function of the piston rings is firstly to provide sealing in the combustion chamber. Second is to scrap excessive of oil in the engine lining. Third is to dissipate heat from piston toward the cylinder, and fourth is to prevent friction, excessive of friction between the cylinder lining and the uh, piston.
Okay. Okay. Then after the question comes what type of refrigerant currently used? What type of refrigerant?
R R410A, R407A, R134A are something, some refrigerants which are being used over there right now, and yeah, if I would know other refrigerant right now at the moment, I only remember R 400 series refrigerant. Basically, yeah, I think if I would have to guess, R134A, R407C, R404A, R410A, and R422A or D. Yeah, these are the refrigerants which are being used.
Okay. Okay. Then after how does alternator works?
Okay, so alternator is basically a device which converts mechanical energy into electrical energy. It basically consists of two parts, that is a stator and a rotor. And two types of windings are used over here, that is field winding and armature winding. Armature winding is wounded on the stator, whereas field winding is wounded on the rotor. What we basically do is we provide some DC supply to the field winding so that it gets excited and magnetic field is created over there. But still, current is EMF is not induced as it is not a rotating magnetic field. For providing rotating magnetic field, we have to give some mechanical advantage or mechanical forces to the rotor so as it rotate and rotating magnetic field is created, and it is done with the help of some shaft or any other mechanical resistance. When rotating magnetic field is created, so EMF is induced. As a result, current starts circulating in the armature winding, and that current is AC. Now we have to charge up our batteries, so we don't require AC. So a rectifier is used over there that converts AC into DC, and this is how we can charge our battery, and this is how an alternator works.
Okay. Then after next question is classification of pumps.
Okay, so pumps are basically classified into two types of pumps, that is a rotodynamic pump and a positive displacement pump. And rotodynamic pump, it is again classified into two parts, that is centrifugal pump and axial flow pump. And when it comes upon positive displacement, it gets again classified into two parts, that is a rotary pump and a reciprocating pump. When it comes upon rotary pump, then it is screw pump and gear pump comes under that category. And in reciprocating pump, so it gear sorry in reciprocating pump, um, it mainly in reciprocating pump, piston displacement reciprocating pump is there and diaphragm pump is there.
Okay. Then after, can you please repeat that Bernoulli's theorem and with its application?
Oh, okay. Bernoulli's theorem I have already explained, I guess.
But I means with
Are you
application,
okay? So
can you just tell
Bernoulli.
applications?
Okay, so Bernoulli's theorem is basically used while we are flying the plane. So there we are using the Bernoulli's theorem, and the other examples of the Bernoulli's theorem, I can only remember recall only one, that flying of the plane is something which I can recall at the moment. If I
Okay.
would be knowing other examples, so I will also share it with you.
Okay. Then after question is components of three-phase induction motor.
Components of three-phase induction motor is basically the rotor, the shaft, the windings, three-phase power supply source, and that yes, these are the mains. These are the main components of a three-phase induction motor.
Okay. Then after the question is valve timing diagram of four-stroke engine, but that you have to draw.
Yes, yes,
So
yes.
we'll move forward. Uh, function of rocker arm, camshaft, and flywheel governor. Okay, let's move it one by one. Function of
Okay.
rocker arm.
Okay. So rocker arm is basically when a crankshaft is rotating. So a camshaft is connected with a crankshaft. So via gear and gear and belt assembly, sorry, gears and chain assembly. Via that, the rotary motion of crankshaft get transmitted into rotary motion of camshaft. And camshaft is a shaft that have lobes in it, which controls the opening and closing of the valve. When that lobes hit the rocker arm, so it provides a pivoting action to the rocker arm, and this pivoting action helps the rocker arm to transmit rotary motion of crankshaft into reciprocate in the linear motion, and which is responsible for the opening and closing of valve. And this is how a rocker arm works.
Okay. Then after working of camshaft.
So camshaft again is very similar to that of this. I have already explained it. But a
Okay.
camshaft is basically a shaft which have lobes in it, and it is connected to the crankshaft via chain and gear arrangement. When crankshaft rotates, so rotary motion of the crankshaft gets transmitted into the rotary motion of camshaft. The lobes move down, hit the rocker arm, and thus control the opening and closing of exhaust and uh, inlet valve.
Okay. Then after working of flywheel.
Okay, so flywheel is basically a device which stores mechanical energy. It is basically a big wheel mounted on an axle, which is basically its main functions are to store to it is basic to provide a constant power supply. The constant power delivery, the main function constant power delivery, storing of the energy, and providing the providing the starting torque which is required to overcome the inertial forces while starting the engine. And whenever there is a torque fluctuation, so there it is used. So basically the flywheel works like that. Whenever we start the engine, we have to give some initial torque to the machinery to overcome the inertial forces. So a starter motor gets engaged with the flywheel. It revolve the flywheel and give its initial movement. Flywheel is connected to the crankshaft. Flywheel rotate. As a result, crankshaft will rotate and piston moves up and down. Then our spark plug gets activated. Our fuel in our intake and exhaust valves get activated, and fuel comes to the combustion chamber. Spark plug hit the spark, and initial movement of the piston gets then piston movement starts taking place. Then power cycle in the combustion chamber starts taking place, and this is how an engine starts, and this is how a flywheel works.
Then after working of governor.
So governor is basically a device which is used for constant power supply for a long period of time, and it basically what it does is it controls the fuel supply for maintaining that constant power supply. And how it does so is like, if our engine is running at a very high speed, much above than our desired speed, so it basically reduce the fuel supply or cut the fuel supply, so as engine's power will again come back to the normal. And whenever the engine is running at a lower speed than our desired value, so it generally pump excessive of fuel and air mixture to in the combustion chamber, so as our speed may increase to the desired value. So basically it is dependent on the load, and it basically controls the fuel supply to control the speed and power of the vehicle.
Okay. Then after what is NPSH?
So NPSH is net positive suction head, and it basically compares the suction amount of suction at the suction pipe as compared to the vapor pressure of the fluid that is being sucked over there.
Okay. Then what is tappet clearance and butt clearance?
So tappet clearance is basically the clearance between the rocker arm and uh, valve stem. And the main function of the tappet clearance is basically it makes sure the proper synchronization in the proper wall timing accuracy is maintained. It prevent wall seats from wear and tear. It basically prevents excessive noises that is being formed while opening and closing of wall, and it avoids such type of things. And it accommodates thermal expansions, and thus ensures proper valves closing and opening properly.
Okay. Did you told about butt clearance?
Oh, sorry, yeah, butt clearance. Now, if we talks about butt clearance, so it is basically the clearance between the connecting faces of the piston ring, and it is important. Like whenever there are temperature fluctuation, it makes sure that the piston did not get stuck over there in the middle. It is it basically ensures that whenever due to heat expansion take place, so proper amount of space is there between the liner and the piston, so as friction produces or less over there. Proper sealing is maintained. It ensure that proper sealing should be maintained over there, and proper heat dissipation should take place. So these are the functions of butt clearance.
Okay. Then after working of marine exhaust gas turbocharger.
So marine exhaust gas turbocharger. Now we know that after combustion, exhaust gases are formed. Then those exhaust gases are stored in the are then sent towards the exhaust manifold, from which are having very high temperature and very high pressure over there. So that high temperature and high pressure exhaust gases are sent there to the blow to run a blower that will suck fresh air from the ambient surrounding or from the surrounding, and the ambient air is fresh and pressurized ambient air is sucked in the system. But this air is pressurized, but the temperature of this air is very high. Now we apply intercooler in between, which reduces the temperature of air that is being sucked. Now it get converted into low temperature and high pressure fresh air. Then this low temperature and high pressure fresh air is sent to the combustion chamber for the scavenging and the combustion purposes.
Okay. Then after what is the difference between governor and flywheel?
So first difference is that flywheel is a big part and governor is a very small part. Okay. Uh, then fly governors application is dependent on load, whereas there is no such load dependence working in the flywheel. Flywheel is always used whenever there are fluctuation in torque, and governor is used whenever we need a constant power supply for a certain constant power supply for a certain period of time. Uh, Governor can control fuel supply to regulate the power, whereas flyover do not have that liberty to control the fuel supply, and it is not engaged with any of these things. So a flywheel can store mechanical energy, but a governor is not a device to store any type of mechanical energy. So these are the differences.
Okay. Then after, what is the difference between endothermic and exothermic reaction?
Endothermic and exothermic reaction. And exothermic reaction is a reaction in which heat is being released in the surrounding, and endothermic reaction is a reaction in which heat is absorbed from the constituents in the reaction.
Okay. Then after, tell some workshop tools used in ship.
There are many workshop tools like benchwise, spanners, pliers, chisels, saw, tap and die, drills, screwdrivers are some of the tools that we use on board ship.
Okay. Then after, we are moving towards Oberoi sir favorite questions. So
Okay.
his first question is, mention parts of four-stroke diesel engine.
So four-stroke diesel engine parts, if you will say, uh, four-stroke diesel engine, it will start again with cylinder block, piston rings, gudgeon pin, connecting rod, crankshaft, camshaft, rocker arm. Diesel engine or petrol engine?
Diesel engine.
Okay, turbocharger, fuel injector, governor are some of the parts that we use over there.
Okay. Then after, your question is how piston and connecting rod is connected.
This connect piston and connecting rod is connected. Piston and connecting rod is connected via gudgeon pin.
Okay. Then after, what is rocker arm mechanism?
So rocker arm I have already explained.
Okay. How camshaft? Okay. How camshaft and crankshaft rotation is related?
So camshaft and crankshaft is rotation is related because whenever the piston moves down, so reciprocating motion is piston is getting converted into rotatory motion of crankshaft, and crankshaft is connected to camshaft via gear and chain assembly. So, with the help of this gear and chain assembly, the rotary motion of crankshaft gets transported into the rotary motion of camshaft, and this is how the crankshaft and camshaft is related.
Okay. Uh, Explain three-phase induction motor. Could you explain that earlier?
Okay, so three-phase induction motor is a electrically powered motor which uses three-phase AC supply for its applications, and it works on the Faraday's laws of electromagnetic induction. It basically consists of two parts, that is a stator and a rotor. We basically gives a three-phase AC supply to the stator winding, so as a magnetic field is created over there, which is rotating with a synchronous speed. Because of this changing magnetic field, an EMF will be induced in the rotor. Because of this EMF, current will start getting circulating in the rotor. Because of that current, and magnetic field will be induced in the rotor. Now, the direction of the magnetic field induced in the rotor will be opposite to the direction of the original magnetic field, and this induced magnetic field will try to catch up with the speed of with the catch up with the original magnetic field, and this will create a torque, and this torque will create a motion, and this is how a three-phase induction motor works.
Okay. Then after, what is saturation temperature?
So, saturation temperature is basically a temperature where the phase change from a liquid to gas takes place without changing its temperature.
Okay. Then after, what is sealing box? Why it is important in centrifugal pump?
So sealing box is basically a type of box which creates sealing between the shaft in shaft of motor and impeller of centrifugal pump. It is important so as any impurities from the motor side do not get into the fluid in the or in the centrifugal pump, or any type of flow or fluid that is being sucked by the centrifugal pump cannot get leaked towards the shaft and cause damage to the machinery. So basically, for the sealing purpose, that sealing box or stuffing box is provided over there.
Okay. Then after, why crankshaft to camshaft ratio is 2:1?
2 is to why crankshaft to camshaft ratio is 2:1 in a four-stroke engine, I guess.
Yes, yes. But it's why. It's here is asking
Yeah,
why.
but because in a crankshaft to camshaft ratio is 1:1 in two-stroke engine and 2:1 in a four-stroke engine. It is because so that it take in a four-stroke engine, the power cycle is completed in the four strokes. Okay, so crankshaft revolve two times to provide one power cycle, and that's why. Uh, for those two revolution one power cycle is created, and that's why the ratio of crankshaft to camshaft is 2:1, I guess.
Okay. Okay. Then why AC is measured in tons of refrigeration and why fridge in liters?
Because the fridge has to cool any specific volume, or a small volume fridge has to cool a small volume, but in an AC we require to cool a big room irrespective of their its volume. So if we will and if we will be saying that we have to we have to sell refrigerator in the terms of tons, so what will happen is that it will not give clarity to the audience or clarity to the consumer, that if from zero point 0.5 or 0.25 ton or 0.75 ton or zero point 0.5 ton, it doesn't make that clarity, and it have to only cool a specific volume. So we generally tells us that it will only make refrigeration up to this volume, but in AC the volume is not fixed, irrespective of the room. If you have a small room or you have a big room, it doesn't matter, irrespective of volume AC will cool whole room. So that's why it is measured in tons, whereas our freezer or reefer system is in liters.
Okay. Then after 1 tons of refrigeration is how much kilocalorie per hour?
I'm confused over there. 3275, I guess. I have to check. I'm not sure about it.
Okay. Then after, what is superheat?
What is
Superheat.
what is super?
Superheat.
Okay, superheat is basically when we apply heat to the dry saturated seam and raises its temperature. So it is what we call superheat.
Okay. Okay. Then after, next question is why some of the pumps are called positive displacement pump?
Positive displacement pumps are called positive displacement pumps because they displaces a fixed a certain amount of fluid from from suction side to discharge side. That's why they are called positive displacement pump, because they displaces exactly fixed amount of volume towards the discharge side.
Okay. Then after, explain cavitation.
So cavitation is basically the formation of the bubbles inside the centrifugal pump. It basically happens uh, when the vapor pressure of the fluid that is being sucked uh, becomes higher than that of the suction pressure that is being over there in the centrifugal pump, or if the suction pressure deteriorates below the vapor pressure of the vapor pressure of the fluid that is being sucked. Because of that, bubbles are created, and these bubble, when goes to the high pressure region, they get burst. uh, and this phenomena is what we call as cavitation, and it also causes pitting corrosion.
Okay. Then after difference between speed of motor and frequency of AC supply given to motor.
This question is a very like confusing one. We have
Okay.
also discussed in groups also, but
Okay.
like speed is related to frequency. Like ns is equals to 120 f by p. So if we will increase the frequency, so our speed will also is also going to increase. The frequency of current will increase, so our speed of motor will be increased. So I think this might be the relation, but the difference is something which I also don't know, and I'm confused over it.
Okay. Then after how vehicle starts at beginning when we use key.
So when we turn on the key, it basically powered the electrical system, and it charge up the electrical, or you give the power to the electrical system. The electrical system gives power to the ignition system that consists of a spark coil, ignition coil, in the spark plug. Now, when our keys are in the on condition, then a starter motor gets engaged with a flywheel and provides the initial torque to the flywheel which is required. So, thus, flywheel provide the initial torque which is required to overcome the inertial forces, and piston starts moving up and down. As a result, our fuel, we have already when piston moves up and down, so our fuel starts getting into the air fuel mixture gets coming to the combustion chamber. Spark plug is already getting powered, so a spark plug give the spark to the fuel in the combustion chamber. And this is how then compression, then power cycle take place, and this is how the vehicle starts when we turn on the keys.
Okay. Then after how lubrication takes place in bikes.
So, okay, I have to charge my. So, lubrication takes place in bike. Basically, there is first of all, centrifugal pump is provided over there, from which oil is sucked from the sump. This oil then passes to the oil cooler, and from there it is passed to the filter. From where any debris, if there is any debris over there, it it gets clean. From there, via thin tubes, via thin tubes, or lubricant is sent. Our lube oil is sent to the different bearings, where lubricate or moving part or bearings, wherever the lubrication is required via thin oil layer. Lube oil goes to there via thin capillary tubes like that, provides lubrication over there, dissipates heat, and then returns back to the oil sump via the gravity. And this is how lubrication in bikes take place.
Okay. Uh, then after the question is what is die?
What is?
Die.
Okay, so if that tap and die, right? So basically, if I have to say, it is a type of workshop tool which is used to create external threads.
Okay. Okay. Then the next questions you have already answered. So
Yes,
we have done with our today's interview mock interview session.
yes.
So thank you, Tushar.
Thank you.
Tushar has given his answers on the best knowledge he has about the questions. Okay.
Yes,
So
yes.
that thank you. Thank you, Tushar.
Thank you, Saket.